All right, so we're just going to get a little practice in here. And I'm going to graph two rational functions, hitting the major numerical characteristics and discussing them a little bit. We're going to do two cubics in graphing form, and a bunch of unit circle 30-second questions. Draw the circle, draw the triangles embedded, look for the ratios. So we'll have at it, and that'll get us some good practice in the early going. This is day 3 on the new topics. Should be coming into focus a little bit, and then hopefully day 4, doing them yourself. And day 29, doing them quickly and well. All right. So we got our input axis, we got our output, got a little fractional function here. So I've got the questions I want answered. What's the y-intercept? You pause the video every time I ask a question. I'm just going to keep going. Y-intercept, put in 0 for x, and I can see 3. 0 gets us 3. When does this function equal 0? When the numerator equals 0, I can see -3. -3, 0. That takes care of that. That takes care of that. Horizontal asymptote. Well, these fractional functions seem to have asymptotic behavior when we put big numbers in them. So let's put 1,000,000 in for x. Substitute 1,000,000. So that's going to be 2,000,006. That's going to be 1,000,002. Okay, and I hope you have a feel for the relative size of that fraction. I think 1,000,000 goes into 2,000,000 twice. Google said, and I did put it in because I wanted you to at least see a decimal one time. I think it was 5 zeros, but let's just say we're pretty close to 2. Both sides, because I could have put a -1,000,000 in. There we go. So that takes care of the horizontal. Vertical asymptote, undefined at -2. Okay, a little slant here, a little problem with the rotator cuff. How's that? It's a little better. Let's move this out of the way a little bit more. -3, 0. That. All right, so there's only one place where I cross the x-axis, and that's it. If I'm ending up there, I got a feeling it's got to do this. And we get sign changes everywhere. So positive is going to go to negative, and negative is going to go to positive. All right, now I can do that because I got some experience with it. You're trying to get experience. And as I said earlier, last few lesson sets, I've been pushing one major theme. You want to know what's going on with the calculation, put some numbers in. Okay, and just a reminder, supposed to know what the square root of 3/2 is as a decimal. All right. So let's plug in, I don't know, how about -1 to see that it's it's bigger than 3. Let's put in -1. -2 plus 6, +4. -2 plus 1, 1. Okay, so -1 gets me 4. It's on that trajectory. You can put some numbers in here like 5. Let's put 5 in. 5 gets me 16. 5 plus 2 is 7. Well, that's a little bit bigger than 2. All right, 16/7. It's a little bit bigger than 2. So I think we can trust that trajectory, and I'll leave it to you to put some negative numbers in. Put some numbers in between -2 and 0 to see, we already did that one, between -3 and -2 to see if you are indeed getting negatives. You will. So when are we less than 0? From -3 to -2, we can see it. But let's say you're struggling to graph these rational functions. Then you could go to a sign chart. We only have 2 critical numbers, -2, -3. And you'll see that if you put in a number bigger than -2, like 0, you get 3, which is not less than 0. So that's false. That's going to be true. That's going to be false. All right, these numbers here are positive. when I'm to the left of -3, I have positive numbers. Positive numbers are not less than 0. Okay, so that takes care of that discussion. That takes care of that discussion. Limit as f of x goes to infinity. Well, as I move to infinity, I think I'm getting very close to 2. So that answer would have been 2. What happens as I move to -2 in a table? All right, -2, here's -2, and I move to it from the left. Well, that means I'm at -4, -3, -2.5, -2.001. And if you drop -2.001 in here, you're going to get -0.01, something like that. And -2.001 times 2 is pretty close to -4. So why don't we just call it that? So how many times does, wait a minute, -2, +4, excuse me. I can see where I'm headed. Well, I hope you're seeing a very big negative number, right? Very big negative numbers here. So that kind of justifies that. So what is that answer? When I go to -2 from the left, the table is trending towards -infinity. Now, what happens when I just go to -2? Well, that implies I'm coming in from above 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -1.5, -1.9, -1.9999999, just a sign change. And you're heading to positive infinity. Here you're heading to -infinity. And if you're not going to the same location, limit really is a y value, right? And if you're not going to the same y value, then we say the limit does not exist. Okay, so that takes care of that problem. Now we're going to use the same questions because I built a very similar problem. And there are some patterns that I hope a month from now you begin to recognize. One of the patterns here is that exponent is smaller than this one. Keep an eye on that. Whereas over there, the exponents were the same on the big players. So let's use these questions here. Let's erase this. Let's erase this and ask the same questions of this function, about this function. And it's good to put these in factored form. Good practice to put these in factored form, x plus 2, x minus 2. And the first thing I notice, I got 2 vertical asymptotes. Nothing's dividing out of the problem. So let's get our x-y axis together and let's go down the checklist. Y-intercept. Well, you better look for the y-intercept in the original or you got to do a little more work over here. So there's your y-intercept, 6 over -4, -1.5. You put a 0 in, -1.5. Might have to move that coordinate, but we'll see. X-intercept, still -3. Still -3 gets a 0. But now we have 2 vertical asymptotes, one at -2 and one at +2. I knew I'd have to move this. So if that's -2, then +2 is here. Okay, and the y-intercept is going to be, I'm going to be positive, negative, positive, so I'll put it right here. No x-intercept, no other x-intercept, so I think I can go right here with this. What did we say it was? -1.5. All right. There's only one place I can cross the x-axis. It's here. Then this has to take on that shape. And remember, we get this behavior when we're close to 2 from the left, which is numbers like 1.999999999, which when I drop in there is -0.1234. I don't know how many zeros. I can make as many as I want. And if I multiply that by something close to, well, this would be close to 4, it's only changing that decimal point. Right? And so that's one of those really small, tiny numbers that's going to fit into something a lot of times. And 1.99999 is pretty close to 2. 2 plus 3, 5 times 2. This is pretty close to 10. Close to 10. How many times is that going to fit into 10? Lots of negative times. So we've kind of answered this question here. We're headed towards -infinity. And on this side, we're going to get a sign change. right? So we've got 1, 2, 3 sign changes. All right, so there's going to be 4 intervals. There's going to be a positive, a negative, a positive, and then a negative. That's what I think is going on. This is a little tricky over here. Looking at that's a little tricky. But what are we headed towards? If we put 1,000,000 in, well, I got 2,000,000 in the numerator, and I got 1,000,000 squared in the denominator. Well, I think I can divide by 1,000,000 here. And I've got 2 divided by 1,000,000, and 1,000,000 is just a kind of a placeholder for a huge number. Could have put 1,000,000,000 in. Could have put 1,000,000,000 to the 10th power in. Bottom line is, looks like I got a positive divided by a positive, and this positive is getting bigger and bigger and bigger and bigger. And as Hudson said the other day in class, the fraction is getting smaller, smaller, and smaller. It's going to 0. But it's positive, so it's got to look like that. It's got to look like that. It's got to look like this. And that's awkward. So how are you going to find that? Well, you got to put a number in between -3 and -2. So let's do -2.5. -2.5. -2.5 plus 3 is 0.5 times 2. 2 times a half is 1. -2.5. -1/2 here. -2.5 minus 2 minus 4.5 here. Minus 4.5 here. Okay. So what do we have? Yeah, we have a positive number. All right. So when I put something in between here, I'm getting a positive answer. And the closer I move to -2 from the left, like numbers like -2.1, well, same thing happened in the last problem, right? We're getting really, really tiny number here, negative, into another negative, all right? Going to get a big positive answer. So let's check out if this is really negative or not by inputting. Remember, this is your input axis. That's your input. I get to choose any number I want. So I'm going to choose something over here because that looks really strange. How about -10? Let's just put -10. -20 plus 6, -14. Hey, hopefully I'm doing that right. -10 squared is 100. Minus 4 is 96. Is it possible that that could be right there? I think so. All right, so let's answer our questions again. Bring the camera over here a little bit better. All right, we got our y-intercept. We did that. We got our x-intercept. We got our horizontal axes. We got our vertical. When is this less than 0? Well, these negative numbers until I get to -3 are all negative, and then we get positive y values. Right? So all of these numbers here will get us below the axis. So -infinity to -3, union, then I'm positive for a short spell, but negative again from -2 to 2. Is that what I wanted? Less than? Yes. -2 to 2, I'm negative again, and then I'm positive. So these are positive numbers. So those x values right there are going to get me positives. All right. As x goes to infinity, we answered that. My y values go to 0. As x goes to -2 from the left, -2 from the left, I'm headed to positive infinity. -2. Well, I changed from positive infinity to negative. I got a sign change, so that's another does not exist. All right, now we're turning our attention to the cubics. All right, you're going to try to graph that. All right, pause the video and graph it. Let's see how much recall you have. 2 days of working with this, day 3. No, this may not be day 3, but it's your 3rd time of real good consideration here. All right, so what do I see? I see something on the left that goes down, something on the right that goes up. The question is, what's happening in between? Well, let's talk about what I see. I see an increasing function at the y-intercept 0, 10, going up at 5 to 1. So that only tells me I'm going up. So at this stage, I don't know if I'm always going up. I don't know if it's flat there, and I don't know if it looks like one of those, but I do know the end behavior. All right, so let's see if we can do justice to the cause. What's the first thing you're looking for? Pausing the video. Hoping you're saying the point of inflection. Hope you're saying the point of inflection. So minus 12 be positive 12 over 6 minus b over 3a, the average of the roots, 2. So I now know that point of inflection happens at 2 what? Let's put 2 in and find out. So 2/3, when I put 2 in, I'm going to get 2/3 of this term. It's easier to plug it in here. 2 cubed is 816. It's easier to get it there. Double that number and change the sign. So that's positive 16. So I now know that negative 32, I'm not done yet, just gets me, if I input the number 2 into those terms, I'm here. 2 times 5 is 10, and another 10 tells me that at 2, I am at negative 12. So at 2, I'm at negative 12. And I think I'm going to be going down briefly. All right. Well, yeah, I know I'm going down because at 0, I'm at 10. So at 0, I'm at 10 going up. So let's put 0, 10 over here. And I'm going up at 5 to 1. Well, it's got to look like this then. Got to look something like that. Because I am going up. Talked about that enough. So now, what's the rate of change here? C minus 3ah squared is what I'm hoping popped into your head. So C is 5. Minus 3, A is 2, excuse me. And H was 2. So we're going down pretty quickly there. 4, 8, 12, 4, 8, 24, 5 minus 24, I believe minus 19. So we're going down at 19 to 1 there, going up 0, 10. So the max should be between 0 and 2, which is an x value measuring from 2, going backwards this way from 2. What's this x value? It's 2 minus the square root of 19 over 6. 3a. All right, so that's close to the square root of 3. That's close to the square root of 3. It's certainly smaller than the square root of 4. Okay, so 24. That gets me 0. That's over here on the upswing. Okay, so 19 over 6 looks like it's positioned well, which means that this is the min, and that happens at x equals 2 plus the square root of 19 over 6. And I believe the last video was all about y. Okay, that tug of war. Had that tug of war discussion in the last video. Hope you watched it. All right, so that's tells us we've got some x-intercepts, right? They are here, here, and here. If you add up those 3 numbers and divide by 3, you're going to get that. And that's all about the geometry behind completing the cube, which is on the playlist somewhere. All right, so now let's do another cubic. Maybe you're a little better at this one this time. Repetition is our friend. So what do I see? I definitely see one of these. Right? Definitely see one of those. It's got to be going down at the point of inflection because I'm going down with a positive a value. If this is positive a and all of these were positive, if that was a positive 10x, I would have had a function that looked like that. I'd have 1 real root and 2 imaginary. And we'll talk about the roots later. We're going to try to tie together problems we did in the first half of the term with this problem. Not yet. Just getting the mechanics of getting a quick graph. All right, so you find the point of inflection. I'm going to answer these questions more quickly this time. I'm just going to do the problem and then see if you can follow. Point of inflection, minus 9 over 3 times a, 3 times 3, negative 1. Okay, that means I'm going down at 10 to 1 somewhere here. So that's 0, 5. And I'm going down at 10 to 1, but I'm going down faster here. All right, and we'll explain that later on as to why as well, but not right now. All right, so what's this X value? I don't know yet. I got to plug -1 in to find the Y value. Better be bigger than 5. -1, so that's -3, +9, +10, +5. So we got 24 minus 3. It sure looks like it's 21. Very believable. That's 5. There's yep. If I made a mistake, somebody's going to let me know. X is equal to measuring from -1 going to the left. All right. Got to get the rate of change here. C minus 3AH squared gets it quickly. So -10 minus 3A was 3. And H was -1. Right? I'm calling this HK. Just like HK, vertex of a quadratic. This is where the pattern emanates from. Right, so what have I got over here? -9, -10, -9. I got another -19. Okay, but I believe it. So I'm going down to 19 to 1. Well, that's a piece of cake now. X minus the square root of 19 over 9. All right, 3 times 3. And that's close to 2, right? And the square root of 2 is about 1.41. So -1 minus 1.41 is to the left of -1. And then this one is x equals -1 plus the square root of 19 over 6. Okay. We can do it with some calculus later in the term because we can see the rates of change of cubics pretty easily. We talked about it in class the other day. It's all connected to the surface area of the cubes. So we'll get to that, just not yet. All right, so now we're going to do some quick unit circle work. You're going to try to find the sine of 7 pi over 6, so on and so forth. And I will just do them out mechanically. In a month from now, I hope we don't have to do any drawings and we just look at it. We go -1/2. That's our goal, just to look at these, so on and so forth. This one here should be √3 over 2, I believe. No, that'll be a half. +1/2, excuse me. 29 pi over 4 should be 27, 28, 29. I don't know. Gonna have to actually think about the calculation a little bit there and stop talking to you. But let's do the first one. Pi, top half of the circle, breaking it up into 6 parts. Good drawings get good answers. Okay, we want 7, so we want that one. And as I bring that up, I hope you can see -1/2 is the height. Remember, hypotenuse doesn't change signs. It's 1 opposite the 30-degree reference angle, -1/2. All right, let me get an eraser. We'll just keep doing this. 19 pi over 3. All right, so pi, top half of the circle, 180 degrees. Circumference equals 2 pi r, and r is 1 unit in the unit circles. Doesn't matter the size of the circle, we're just calling the radius 1. So pi over 3, another good drawing, which means there's 6 of these all the way around. 6 pi over 3, multiples of 6. 12 pi over 3, not multiples of 6, but double multiples of 3. 12 pi over 3, 19 pi over 3 is 18 pi over 3 is 6, right? And we want 19, which is this one, and the cosine is the width, and we can see that that's a half. 30, 60, 90, the smallest side is half the hypotenuse. Okay, so that one's done. 29 pi over 4. Remember, pi over 4 is 45 degrees. I hope we do that soon. If that's 1, then that has to be a half. And that has to be a half according to Pythagoras, which means that each of these has to be the square root of a half. Those are the side lengths, right? If that's 45, and that's 90. 45, 45, 90, right? Okay, so what's the square root of a half? The square root of a half could be written as the square root of 1 over the square root of 2, which is equal to 1 over √2. If I rationalize that, √2 over √2, I get an exact answer of √2 over 2. Yeah, you saw all of that. All right, and I've asked you to memorize √2 over 2. 0.71. So taking a little time because it's the first time we've done the 45, 45. Does it make sense that 0.71 is that length and 0.71 is that length. I hope so. Remember, what's 0.7 squared? 0.49, which is pretty close to a half, and we had a half and a half. All right, so I put some thoughts in your brain. Let's hope they registered. If not, you're going to keep hearing me say it, so catch on at some point, I hope. So instead of tangent, it's easier to work with a hypotenuse of 2, just doubling everything. And so what is root 2 over 2 doubled? Root 2. Okay. Or if we have chunks of 4, really doesn't matter all that much, right? If we say that here, it doesn't matter that much. So we'll go with this one this time. So where's 29 pi over 4? Well, 8 pi over 4 is once around. And therefore, 29, closest multiple to 29 is 28. So 28 pi over 4 is over here. Do the math. How many times is 4 going to 28? 7 pi. Even pi on the right, odd pi on the left. I need one more. That's my triangle. I have negative root 2 over 2, negative root 2 over 2, and I have another negative root 2 over 2, and I have 1. What's that divided by that? Sure looks like it's positive 1 to me. All right. Minus 17 pi over 3. Pause the video, you try it. Well, I know going this way is the negative direction, and minus 6 pi over 3 is once around. So what's the closest multiple of 3 to 17? It looks like 15. So minus 15 pi over 3 is over here. No, it's 18 pi over 3 is what I should have done. Minus 18 pi over 3 is over here. Doesn't matter. I mean, if it was minus 15, I got to go 2 of them anyway, right? If it's minus 18, I got to back up 1. Not a very good, yeah, that pi over 3, yeah, that's a good drawing. So that's 1. And I'm looking for the sign, so root 3 over 2. Okay, and the last one, minus 25 pi over 6. You figure out what's close. Didn't want to erase that, so let me put that back here, and I'll fill that in as we go along. All right, so I see whoomp, 1, 12 pi over 6. Whoomp, 24 pi over 6. I'm over here, 24 pi over 6. So going around backwards, 25 is 1 more. So where am I? Chunks of 6. 1, 2, 3, 4. I'm on that location right there. Remember, this is minus 24 pi over 6. And I'm going 1 more. So what is that altitude? I hope you're starting to see a decent drawing. Minus 1/2. Okay. And this is day 2 of our unit circle work. Day 4 is usually magical, where you start doing them a little better yourself. All right. And the last thing, I wasn't going to do this. I was just going to do these 3 major topics, but I did plug in one more thing to consider. Hoping it makes a little more sense. A quick sketch here. Well, the sine function does not work on years. No. No, the sine function works on angles. All right, so if you snip a circle and you open it up, it becomes linear. And we can make 1947 act like an angle, because that's a line. We can write an equation of a line. Where is 1947 in terms of an angle? A max. So I have a choice. I can either write it as a sine function or a cosine function. Okay, so if I do it as a sine function, I think I want 1947 to act like this location on the circle. Yes, I've got it over here. Let me bring this down a little bit more. Okay, max for a sine function occurs right there. A min occurs here. And we want the max. Well, that's pi over 2. And really, the adjuster here is the multiplier. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. 5 pi takes me to this location. So that's the next y value I want, but we don't know. We don't have to say 11 pi over 2 here. We don't have to do that because we already counted the change. All right, so the change is 5 pi. And that takes how many years? 2000. So we're now making 2000 act like 11 pi over 2. 1947 as pi over 2. And how far is it from pi over 2 to 11 pi over 2? 10 pi over 2, which is 5 pi. So what's our linear function? 5 pi, change in years, what is that, 53? And we're going to let our angle, x minus 1947, right? So I plug 1947, we want pi over 2. Well, there it is. That's just the equation of a line. And then we got to look at our midline, which is 100 to 50. So 75 is our midline. So I can put the 75 here. I'll do it that time. And how do I get from 75 up to 100? 25. There's that function. Now, if I did it as a cosine, the cosine is a max at 0. All right, that's our maximum width of 1. So 0, 1 is that coordinate, or 1, 0 is that coordinate, excuse me. All right, cosine's width. So I want 1947 to act not like pi over 2 now, but to act like 0. And I'm still going to go up 5 pi. So nothing changes here except for the fact that we're doing it as a cosine curve. We still have 5 pi over 53. And we still have x minus 1947. And the question is, do I really need to write plus 0 here? I think not. And so I don't have to do that. So there's my linear function. What else is true? Well, the rest of it's true. It's the same as what I had before. Amplitude still 25. Midline still 75. All I'm doing is changing my perspective on, am I using the widths, maximum to minimum widths, or am I using heights, maximum to minimum heights? I've taught you the sine function first because I think it's visually easier to make that connection, that this is a linear function. It's just like a belt. You take it off and stretch it out. You can think of it as an x-axis. And so now we're doing what? Converting years to angles, years to angles, angles, sine and cosine, get us numbers between 1 and -1. What are we doing with the 1 and -1? Amplifying them, making them 25 times bigger, and measuring not from, a baseline of 0, but a baseline of 75. All right, so hopefully that means more to you as we keep talking about it. All right, I got to go find the marker cap. I don't want this to dry out. Hopefully I'll find it. And everybody stay safe and warm, and we'll see you in class.